So as mentioned above, acetic acid by itself is not a buffer because it's really only able to counter the effects of added sodium hydroxide or hydroxide ions from base because I have quite a bit of acetic acid that did not ionize. On the flip side, I have a very small amount of acetate ion, so I cannot really add very much hydrochloric acid at all. I'm going to consume that acetate ion pretty quickly. And so what I could actually add is more acetate ions, but I can't just go to the back room and grab a bottle of acetate ions. Instead, I need to make a salt solution out of it. And so sodium acetate might be a nice choice for a couple reasons. First of all, sodium is soluble with everything, and it also doesn't hydrolyze, right? So we don't want the cation here to hydrolyze and produce hydronium ions on its own. So it's soluble with everything, and it's also a neutral cation. It doesn't hydrolyze, so that makes it a good choice. And so by adding sodium acetate, I'm now going to increase the concentration of acetate ions in the solution. So that's going to cause my equilibrium to shift left. So the equilibrium above is going to shift to the left, and as a result, the pH is going to get higher. Right? So the pH is going to increase because I'm shifting left, and I will produce less hydronium ions now. But that's okay because now I will have a solution that will be about a pH will now be about, after the shift, if you created an ice table, the pH would be about 4.7 if I had equal amounts of acetic acid and acetate ions. And so the pH would be about 4.7, but now I'd be in a position where I could counter the effects of adding hydroxide or hydrochloric acid because I have equal amounts of acetic acid and its conjugate base, acetate.